A very good morning to all, and I welcome you all again for the second day of FTP on artificial intelligence and neural networks. Today, the resource person has to be taken the topic as computational intelligence and neural networks for research. Basically, our human brain works based on the neurons, as it is same how the machine works based on the neural networks. It is our day to FTP. Now, I welcome the resource person, Dr. Ali Arul Ma'am, HOD, Department of Computer Science in Presidency College in Bangalore. She has completed her PhD in Hindustan University. She has more than 20 years of experience in teaching field. She has published more than 25 national, international conference and journal papers. She was delivered many guest lectures in artificial intelligence, machine learning, computational intelligence, soft computing, and so on. She has membership with CSI and IEANG. Now, I invite the resource person, Dr. Ali Arulma, to present her valuable speech. Thank you. Welcome you, ma'am.
Thank you, ma'am. Thank you for giving the opportunity to deliver a lecture on computational intelligence and neural networks. I hope the screen is visible. Correct, ma'am? Yes. Shall I start?
Yes, ma'am.
Yes, ma'am. Very good morning. The session what I'm going to give today is computational intelligence and neural networks for research. Let me start a day with a quotation. Knowing what to do is more important than knowing how. That means what? We should know how to do the things perfectly. The implementation is more important than what exactly in our field, especially in computer science, right? So let me take the formal definition of AI, artificial intelligence. It is a computer program or a machine. Okay, so a machine which has the capability to take decision on its own by considering the present situation. It mimics the human for decision making process. We call it as AI. It assists in everybody's life, knowingly or unknowingly. We are using AI in our daily life. Just to name a few examples, to read our emails, get driving direction, or to start a new business, whatever it could be. So, in our daily life, knowingly or unknowingly, we are the users of a part of AI, artificial intelligence, right? So in various walks of our life, everybody is using smartphone, even starting from kids due to COVID situation. We are forced our kids, college students, school students to use smartphones. Before, we don't allow them inside the classroom with mobile phones. Now we are allowing them only with mobile phones. That is what the scenario what we are facing today due to COVID-19 situation. All right. So the advent of technology has been improved a lot due to COVID situation. Today I am delivering a lecture. I am sitting in Bangalore. You are sitting in your own location, and we are connecting each other. How? Only because of technology, AI, and computational intelligence. The technology what we have today is really amazing. And then smart cars, drones, social media feeds, music, media streaming, video games, online advertisement, and then ride sharing apps, banking and finance, and so on and so forth. These are all the various fields where we use AI in our daily walks of our life. All right. I hope you all will agree for this. So, next, the formal definition of AI, right? Artificial intelligence. So we all know the basic definition. It mimics the human brain and it has certain algorithms to process. How it perform the process? First, it learns the pattern, identify the pattern, and then based on the pattern, it stores and it gives the results using various algorithms. Using various sigmoidal function, it generates the results like how the human will be able to generate a solution for a particular problem in a similar way. It mimics the human interaction, it mimics the human behavior, it mimics the human decision making process. That is what all AI is. It is amazing. What will be the future? We have to wait and watch about AI. How AI can help me? Yes, in each and everything. As I told you, just an example, emotion deduction based on the moods of the customer, right? Suppose if we are traveling, when we travel, if we met with an accident, AI help us to take a on-spot decision. What is next? What could be, what we have to do it, and how we have to behave as a good or a better citizens, all right? So based on the situation, AI will be in a position to help us to make any sort of decision. Now, AI is a vast field. It has various parts, right? Like cognitive system, planning, robotics, machine learning, NLP, perception, knowledge, neural networks. Out of this, what we are going to discuss today, what I am going to cover it in today's session, it is all about neural networks. How exactly the neural networks, we are going to use it in our research field, and what is neural networks, how exactly the process, and what all the various process involved in neural networks, how exactly the operation is going to be happen, how we can implement it, and how we can generate results and write a paper based on neural networks, right? That is what we are going to discuss in detail in this particular session. Yes, before getting into detailed session, just you can observe this particular scenario. How exactly the interaction is happening between one human and the other human. This is not the exact human-based process. But here, exactly, the AIs take over the human interaction using machines as well as the algorithm, various equipments, how exactly a human being interacts between each other, a person and a person, right? A communication between one person and the other person is taken over by the technology that we call it as AI to make any decision or whatever it is, right? So, here, let me start with artificial neural network, ANN, we call it as, all right? So, it inspired by a biological nervous system. Actually, it consists of various neurons connected by synapses, that all those generic information everybody knows, right? So, the basics. So, ANN, a neural network, right? So, your neural network consists of various cells, neurons, and each and every neuron is associated with weights, and there is a propagation rule. Using those rule, we have activation function. Very, very important for neural network is activation function. What type of activation function we are going to use it? By accepting the input from the external source, it is going to process along with the weights, and when it is processing along with the weights, what type of activation function? Here, activation function is nothing but it is a sigmoidal function, it could be, or it could be a tangential function. So, what type of function we are going to use it to generate a result? And once you generate it, you will be able to generate a result in the output unit, okay, for each and every input, whatever you have gathered. But how exactly the entire process is going to happen? By using learning process. There are different learning process in neural network. I am going to explain you in the forthcoming slides, right? So here we need to understand artificial neural network in two different viewpoint. One is technical viewpoint, the other one is biological viewpoint. So technical viewpoint in the sense like what exactly the ANN is going to do. Like here, the prediction of a future state of a system require massively parallel and adaptive processing. That means what? You're going to predict the result for future. For example, what will be the status of COVID-19? Now we are hearing it third wave, fourth wave, whatever it is. What will be the third wave and how it is going to affect and whom it is going to affect? Okay, lot of survey has been done, lot of analysis has been done, lot of classification has been done by IIT students. We have seen, we have read in the paper how they have done using ANN, right? Artificial neural network plays a major role in doing all predictive analysis, classification, categorization. When you are giving a huge amount of data, when you are processing with huge amount of data, yes, it has the capability. How it is going to perform all those process, That is what I'm going to explain in today's session, right? So biological viewpoint, it is nothing but the human brain operation. How exactly the human has the tendency or the capability to process and generate or providing the response for each and everything. So in a similar way, artificial neural network is replicating the operation of a human being in the form of artificial neural network. That is what we need to have a clear idea, clear vision, how exactly the human brain is being replicated into artificial neural network to accept and generate the results. So we call the building blocks of neural network as neurons, right? So neurons, we know that each and everything, okay, whatever the inputs we are going to give, we call it as input neurons. Once you give the input, each and every input will be associated with weight. Here we call it as weight. So along with the weight, okay, we will be passing on to activation function, and then we'll be getting the output. Okay, now here all the informations whatever we are going to transmit, it is going to be transmitted in the form of electric impulses. We call it as spikes. The frequency and phase of these spikes or encodes the information. Here, how exactly, how fast our human brain works, in a similar way, the neurons in the neural network, it works so faster and it takes a decision in an enormous way in a confined area with a proper solution for a human being or for a particular process or for any type of problem. Exactly, right? So here, ANN could be either you can use it for a hardware implementation or for any software, a computer program, right? So it strives to stimulate the information processing capabilities of its biological exemplar. That means what here? Based on the biological behavior, the ANN has been designed, constructed, how exactly the human brain works. In a similar way, the software, what we are going to develop, the hardware implementation, what we are going to do, it is going to provide the response, provide the operational behavior to the user for various applications, right? Yes. How exactly the human brain works? Yes. Billions of neurons are there inside the human brain. For each and every question, we will be able to respond so quickly by accepting the input from the external resource. In a similar way, a neural network will be able to accept the external input and generate the result in a quick manner using its input neurons and weights associated with it with the help of activation function. So this is the general one, like in a biological manner, we can say dendrite, synapse, axon, nucleus, all these are the various parts of a neural network in biological behavior pattern, how exactly our human brain works. I don't want to spend so much of time on introduction part, okay? So this is, everybody knows this basics. So here neuron is connected to other neuron, about 10,000 synapses. The connection, how exactly one neuron is interconnected between the other neuron. This is the sample structure and how the neuron receives the input from other neurons. See, when we say there are 6 inputs, there are 10 inputs, there are 15 inputs, how they are going to interact between each other using this synapse, axons, all those things, right? Once it gets the connection between the interaction, then finally it will be passed on to what? This is the biological behavior of the entire neuron, how exactly the axon, how exactly the dendrites, how exactly the nucleus is a central part of this neural network. Okay, so how exactly it is interacting between each other and how it is going to generate the results from one unit to another unit, right? Input. Here, as we all know that, here neural network has 3 different units: input, hidden layer, and output, hidden unit. Okay, so how exactly the neurons are going to transmit the data between these 3 different units? Exactly as I told you, look at here, these are all your external inputs, and this is your weights which is being associated with your inputs. And how are we going to calculate this weight? See here, x0, x1, x2, and so on, xn, or your inputs. And this W0, W1, Wn are called as weights. So we need to multiply this weight factor with your input, external input. And then the summation of those things, we need to process it and pass on to activation function. Your activation function could be either it is a sigmoidal function, all right? Okay, tan-sig, log-sig, and all is there. So either you can use the tan-sig function or log-sig function, or on experimental basis, which function is going to provide you the better results. Because from time to time, it is a all dynamic behavior. From time to time, the results keeps changing. But which is going to give the better results? You have to do it based on the experimental analysis by doing all kinds of analysis with various activation functions. At least three basic functions are available using NN tool also. All right. So using those activation functions, we can do analysis on trial and error basis and generate the output. This is just a scenario how exactly the artificial neural network works. So by accepting the external input, weights, and then processing unit, and then this is the output, the final one, what I am highlighting here. This is your final output. All right. I hope it is clear for all of you. Next, look at this. This figure shows you exactly the replica of the previous image. As I told you, these are all inputs, x1, x2, x3, x4, x5, and these are all the weights. And this we call it as summation unit because we need to integrate everything together. And then we need to pass on to transfer function to generate the output to take final decision. All right. So this is clear. Again, this is a notation. How exactly we are going to represent the equation? As I told you, input unit, processing, output unit. Here, input unit, only your input neurons will be there, x1, x2, and so on, xn. And the summation, you're going to integrate all your inputs with associated weights and other things, and then pass on to function and generate the output y. This is how it appears. As I told you, see, when you look at this particular diagram, you'll be able to understand exactly how we are going to do the summation process by integrating the input as well as the weight and generating the output y. All right. So this is between three different layers. As I told you, anyway, I'm going to cover it on what are the three different layers we have it in neural networks. So all the input comes under input layer, and this processing comes under here hidden layer, and this comes under output layer. All right. So as I told you, transfer function or activation function plays a major role here by accepting the input and processing and generating the output. All right. This diagram gives you the exact operational behavior of neural network, how exactly the operation is happening over there. All right. So next slide, look at here. You may have okay, how exactly the weight is being calculated for each and every neuron. Look at here. See, x1. x1 means all the weight is being interconnected here. What are all the weights we have used? Similarly, x2. x2 is interconnected to all the weights. xn interconnected to all the weights. And then we need to summation all the weights together. It is not only one input and one weights. How are we going to integrate all the weights together and all the activation function for input layer and output layer, hidden layer? What type of activation function you would like to use, and how exactly we are combining this activation function for all the inputs? How are we doing the summation process? Okay, the output of a function is nothing but here the input affected by the weights as well as with the transfer function or activation function, and then finally we generate the output. When you're generating the output, you will be checking the difference between your actual and the prediction. All right. So when we are comparing, when we are doing the comparative analysis between the difference between the actual and the forecasted or the predicted value, if your mean square error is more or less, based on that we need to do the trial and error basis. You have to do a lot of experimental operation based on the result. If the mean square error is, whether it is a root mean square, RMSE or MSE mean square error, whatever it is, the difference between the actual and the prediction, the whole square, when we do and when we calculate the percentage of the error rate, then you need to do a lot of adjustment in the weights. Okay. So based on adjusting the weights, in a dynamic fashion, in a dynamic manner, we will be able to generate the appropriate results. As I told you, the general layers, three different types of layers, what we have in neural networks: input layer, hidden layer, and output layer. All right. So this is the first one is input, and in between the process, what we are doing with a function, that is hidden layer and the output layer. You may have a doubt whether I can have only one hidden layer. No, it is not necessary. You can have multiple hidden layer also, or a single hidden layer also, depending upon the type of application, depending upon the type of result what you expect. You can use, but it is going to be a little more complex when you have multiple hidden layers. Maybe we can use it with one hidden layer and generate the result and check the accuracy. Suppose when you're having multiple hidden layers, your problem become more complex, all right? And then you might be able to generate a good result or bad based on the type of application, type of inputs, type of the data, whatever the data set you have. Accordingly, you'll be able to generate the results, right? So next, artificial neural network. What ANN can do here? As I told you, you have to select the network topology. That means what? How many number of inputs you're going to use, and how many number of hidden layer you're going to use, and what kind of output you are expecting. You need to have a complete idea, and then it has to learn from the experience, specifically by trial and error basis, as I told you, right? So it is a continuous process. Trial and error means processing the input and producing the output is a continuous operation. It is going to happen in a continuous manner without stopping, all right? But when it is performing the operation, you need to evaluate the result between the target, right, and the actual one. The target, what you expect. Are we getting the expected output? If you are not getting the expected output, what we need to do in neural network, right? Yes, the major role is we need to adjust the weights. By adjusting the weights, by adjusting the appropriate weights, we will be able to generate, as well as we need to choose the transfer function wisely for appropriate data, for appropriate application. All right. So here input layer with 2 neurons, and hidden layer, one hidden layer with 3 neurons, and output layer with 1 neuron. Look at here. It is just a simple XOR, exclusive OR example. Just I have taken just to make you all understand better. All right. 2 neurons here. We have 2 input neurons in input layer and 3 in hidden layer and 1 in output layer. Exclusive OR, we all know the operation of exclusive OR. When we are giving the inputs at 0 0 and 1 1, or 0 1 or 1 0, what will be the output we get? All right. So here, how it works exactly? Yes. So for XOR operation, we'll be reading the input. Suppose if your input is, as I told you, if you're giving the input as 0 0 or 0 1 or 1 0 or 1 1, whatever it is, we have to set the initial values and the weights in a random manner. The truth table of XOR, we all know what is the truth table of exclusive OR, right? So the exclusive OR expression says that, what is that? It is like we can say x dash y plus x y dash, normally exclusive OR, right? We can say x ring some y also in short form, right? X dash y plus x y dash, what is the output? Suppose if you're giving 0 and 0, if you're calculating, that is the output, if you're getting is computing an output as 0.60543, and the expected output is also 1 and the same here. See here, difference 0.60543. Suppose if you're getting some kind of a difference, then you need to modify the weights accordingly. Suppose if there is no difference, then you will be able to generate a result immediately. Otherwise, you need to perform the operation again and again until the condition is met. Until you get the expected output, you need to perform the operation a certain number of iteration. We need to do it again and again until it reaches the threshold or the saturation point, we can say. Okay. Accordingly, we need to stop the operation. This is just an example. Okay. So when you're designing a neural network, what are all the problems we face and what are all the things we need to remember to design a neural network for a particular application? Yes, we need to design the initial weight. Initial weight is very, very important. That is initial weight can be assigned in a random manner between -1 and 1 plus 1. Or it is just an initial example I had given. You can set the value according to your choice, according to your application based on experimental analysis. Also, we can set the values. Initial value is normally between the range of -1 to +1. Right. Next is transfer function. How the inputs and the weights are combined to produce the output. What type of transfer function I'm going to use, right? That is very important. Error estimation. Yes, very, very important. By looking into the error estimation, we need to take a decision. How many number of times we are going to execute it? Are we getting the right output for the given input? Are we getting the right results? If there is a if the result is not accurate, what is the percentage of error I am getting? So to reduce the error rate, what I am going to do? Yes, weight adjustment. We are going to adjust the weights, number of neurons, data representation. Maybe you can do a certain analysis in your data, and then size of training set also plays a major role. In neural networks, if your data set is too small, sometimes we may not get better results. If your data set is huge and the system is able to identify the pattern using learning process, and definitely your results will be better when your data set is huge, normally in neural networks. If it is too small, when you're executing or experimenting it many more times, you'll be getting a different results in a dynamic manner. All the results may not be on the same phase. You'll be getting a different results. You will not be able to come to any sort of conclusion. So on what basis I need to consider whether the result is wrong or right, right? So the size of your data sample is also very important when you're designing a neural network, right? So next, a major part is transfer function. Either it could be a linear function, you can use it. The output will be always proportional to the total weighted input when you're using a linear function. Threshold, that is the maximum saturation level. Beyond that, you cannot generate, or beyond that, we cannot put anything. All right. You can use the threshold function. Non-linear. Okay. The output varies continuously, but not in the linear manner. As the input changes, it keeps changing. That is a non-linear transfer function. So your transfer function could be either linear, sometimes based on your data pattern, or it could be like till the threshold level, you can provide the data and generate the results. Non-linear, in a continuous manner, you can change. Yes. The next one, as I told you, error estimation in the beginning. The error estimation is nothing but the difference between the prediction as well as the actual value. So the difference between the prediction and actual value, we can calculate using various formulas are available. Either you can use mean square error or root mean square error. Okay, anything, any formula you can use it to find out the exact difference between the actual and the prediction. Based on the percentage of error, we need to fine tune the parameters of the ANN, what we design for our particular application. All right. Suppose if you're getting a better results, yes, it's well and good. There is no issues at all. Suppose if you're not getting a better results, then of course you need to look into it and fine tune the values, as I told you, after error estimation followed by the weight adjustment. So what are all the possible weight adjustment we have? Accordingly, we need to adjust the weight, right? So as I told you, how are we going to adjust the weight? By assigning the inputs and the weights based on the calculation. How exactly? There is an algorithm. Everybody would have been heard of it. Whomever is doing research already, who has done the research, and who all have a neural network little knowledge. Everyone knows about, it's a famous algorithm, back propagation algorithm, right? Using feed forward neural network. Using back propagation feed forward neural network, we can do an amazing process, right? So just I have taken a back propagation algorithm for explanation. It is an example of supervised learning. as we all know, there are different learning process, supervised learning processes there, and supervised learning processes there, right? So supervised learning process means here it requires assistance to identify the inputs whatever we provide. Based on the pattern, it takes the decision and generates the results by minimizing the errors. Okay, so here error at the hidden layer will be of average when we are using a supervised learning procedure. That means there is an assistance to do the process, right? Hidden layer networks are trained in this way when we are using this learning process, supervised learning process, how exactly it supports, right? So here in back propagation algorithm, just I'll give you a brief overview here. N is a neuron, right? NW, these are all the common terminology what we use in back propagation algorithm. NW is one of N's inputs, that is the inputs what we use. When we use the notation N out, it is to represent the output. And N, this is for the weight calculation. Delta NW, NW is along with the input and weight, how we are going to calculate this one. NW is equal to the new weight, that is the new weight plus delta NW along with your input weights, how exactly we are going to calculate it. And this is the calculation factor, okay, to calculate the error. The next one, this is to calculate the weight and then the final between the input layer and the hidden layer. And error factor is nothing but the difference between the expected output and the actual output, right? The difference between the expected output and the actual output. Based on this, we will take the decision. How exactly, what is the result? And based on that, we need to take whether we need to increase the number of neurons or we need to increase the number of neurons in the input layer or in the hidden layer, or how we are going to adjust the weight, right? So accordingly, we can reduce the number of errors to improve the accuracy, right? Suppose if you are using very less number of neurons in our neural network, the accuracy will be lower and the system will not be having the ability to learn. So better to have little more neurons. Suppose if you're having very less number of neurons, let's say 2 or 3, then it has a lower accuracy and the system will have the inability to learn the pattern. It will not have the opportunity to do a lot of analysis, all right? So better to have the optimal number of neurons. Optimal number of neurons in the sense the required number of neurons. When we will come to know the required number of neurons is only these many number of neurons for my application. It is not possible unless we put our dedication and commitment and the hard work. Yes, suppose let's say in MATLAB, if you are using NN tool. So in NN tool, there is a option. You can easily work. You can do a lot of miracle in that. What kind of a miracle you can do over there? Yes, as soon as you type NN tool, you will get a window. In that window, you need to give your number of inputs, input neuron and number of layers and what type of tansic logic function you're going to use and other parameters of neural network. Apart from this, we have the basic parameters or a predefined parameters we can say. That is momentum. We have to give the exact momentum rate, learning rate, everything and at what speed it is going to learn. All right. So the learning speed we need to give, the momentum we need to set. All those things, the default values you can use or you can do the modification in that. Accordingly, it is going to generate a result. And then when you execute stepwise, you will be getting a graph between the difference between the actual and the forecasted values, right? Or based on which you can take a decision, right? So this is just a simple gist of how exactly we can do the process. Now, data representation. You can do a lot of, you can use any type of data for your research or for any kind of academic purpose in neural network. Suppose let's say if you're using a picture or a text means pattern is very important. Picture means pixel intensity is important. If it is a numerical number, we don't have to worry. Suppose if you're representing a data in a numerical form, then from Excel, you can upload the file .xls into your MATLAB or any other tool what you're going to use in Python also. You can load your XLS file directly either in Python or in MATLAB, whatever you use as a comfortable tool. Directly, you can upload your file and process the data. You can clean the data and then you can use it. But when we say, suppose if you're working in image processing or any text processing or text mining based operation, pixel intensity and a pattern is very, very important. We need to use appropriate pattern. The next parameter, as I told you, the size of training set is plays a major role. Yes, if data set is too small, okay, then it won't fit in anywhere, in any place. So let's take your, suppose you're going to work in a short-term and long-term process. When we say a short-term process, it is only for few days. Let's say it is only for 5 days. Then you cannot execute, you cannot get a better results. The system will not be able to do the process in a very efficient way, right? So when your data set is huge, and whenever we have a complex problem, to find a solution for a complex problem, we need to approach or we need to use a neural network. So samples, the number of data what we use plays a major role. Sample must represent a general population or must contain a members of each class. That means you need to have a category, right? Suppose let's take our current situation only, COVID situation. Yes, if you're going to perform the operation prediction after, now they are saying third wave, everybody is worried, everybody is scared. Now the children education has been completely spoiled, ruled out because of COVID situation. We are facing a lot of problem, right? So to take some kind of a decision, we are using a neural network. Just assume in that way. So in that scenario, we are going to process it. Suppose if you are going to do a zonal wise prediction. Now the government of Tamil Nadu has given 3 different scenarios. For example, for different states, for different districts, for 11 districts, one rule, for 13 districts, the other rule, for 20 districts, the other rule, like that they have framed it. For Chennai zone, they had released all the norms with little restrictions. So by considering the present situation, from now, after 3 months, what will be the COVID situation? Yes. And what will be the scenario of education, higher education or school education? Yes, we can do a lot of miracle, lot of analysis we can do. We can do a lot of prediction, predictive analysis, classification. We can do a lot of miracle in this. Yes, by collecting all the essential data, right? So different age group who all have been affected and how many age group people are there in the current in Chennai city in a particular location. By collecting those data and their lifestyle, their structure, either in online mode or in offline mode, however the possibility is there, if we collect such data, nowadays in net itself, it is available, different set of data. So using those data, we can provide lot of, we can invoke lot of operations, we can improvise the results and whether size of data, as I told you, if you consider only Chennai, you'll be getting the entire Chennai population. If you take, yes, of course, the data set will be huge. Suppose if you're considering the entire Tamil Nadu, then your data set will be more huge. Then the result will be still more better. Or if you're dividing the Chennai into different regions, Chennai East, Chennai West, Chennai North, South. Again, zonal wise also you can do the analysis and you can predict the scenario, right? So why I am saying all this example is the size of training set. When you're integrating, the results will be better. When you're doing it in an individual manner, the results will not be that good when we compare with a huge amount of data. That's what I'm trying to explain here. Yes. Yes, learning paradigm. How exactly it is performing the learning process. As I told you, supervised learning, unsupervised learning, reinforcement learning. These are the different learning methods, right? So as I told you, supervised learning is by looking into the pattern. Yes, by looking into others, I will learn something and I will implement it, right? So here network has the knowledge and network has the ability to learn the relationship between the input and the output, and then accordingly It adjusts the weights and train the network and perform the operation. That is all about supervised learning. All right. So unsupervised without any assistance, it is very faster than supervised learning, right? Where we use this to find out the structure within data, wherever a clustering or a compression techniques we use, in those operations, we use unsupervised learning methodology. It doesn't require any assistance at all. It does the operation in an independent manner. It has the freedom on its own to find out the result without any assistance, and it is very quick. Okay, so where in clustering, in grouping, in compression, the process of reducing the exact size of the file from the maximum to minimum without losing the quality. So in that scenario, we can go for unsupervised learning process. Next, reinforcement learning process. It's here weight adjusting is not directly related to the error value. That is very, very important. Error value is used in a random manner by shuffling the weights. But here, the disadvantages, it is little slow because of the randomness, because we are choosing the weight here in reinforcement learning process. Weights are chosen in random manner. When the weights are chosen in random manner, the learning process, the learning rate comes down. The learning rate comes down. Okay. As I told you here, training and testing. When we take neural network, the two major part is training process and testing process. All right. So when we take 100% of the data, normally we use 80% of the data for training and 20% of the data for testing. Okay. So then we will compare the training data and the testing data. Already we have done the training process with 80% of our data. So the network has the knowledge of providing the essential operation weights and other functionalities of neural network in a better way. All right. So once the training is over, then we will go for testing. Normally for any kind of a research process, we does either 80-20 or 60-40 or 70-30, depends upon the application and depends upon the necessity. We can divide it. The majority as a global perspective, when we look at it, it is 80-20. 80% of the data we use it for training and 20 we use it for testing. All right. So here, once you train the neural network, all right, once you finish of your training, then we will do testing. Sometimes what will happen, the test data gives poor results. Why test data gives poor results? There might be some kind of a error in your training pattern or in your input data. We can't say why it is giving a bad result. Then you need to do a load of analysis in your input data as well as the input pattern, what you have given, and the sequence, what you have given, and what type of value you have given in your inputs. All those things we need to check, and then we need to go back to the training process of your ANN. All right. So once we finish this entire process, then we can repeat the process again and again as we discussed till it reaches the threshold level or it satisfy the condition whatever we have, right? So here in ANN training, convergence point is very, very important. What is mean by convergence point? Okay, what is convergence point here? How many number of iterations you are using with a required number of input neurons and required number of hidden layers, and you're going to train the network with the associated weights, right? So when you're using that, how exactly it is going to, the curve is going to generate, how exactly the convergence curve. If your convergence curve has a lot of dip and ups and downs, then definitely it is not up to the mark, right? Then you need to analyze the network again. You need to stop the algorithm. You need to adjust the weight. What are all the best weight? Then what will be the ultimately, what will be the result? Your solution stuck into local minimum. local minima. We call it as global best and local minima here. Global best is your best solution. Local minima is your poor results. Okay. So whenever you stuck in local minimum, what we can say is there is a problem either in your algorithm or in your design pattern or with your data set. So we need to look into it. Accordingly, we need to rephrase or completely we need to revamp the entire structural pattern as well as the data set. This is just a sample. Suppose here over training ANN can be made to work too well on training set. Yes, in training almost all the time we get better results, but in test we get little poor results in some cases. Yes, of course it happens. In training, the amount of data is huge, but in test case, your data set is relatively less, right? Yes, this graph shows the performance against the training set data, against the test set data, right? Of course, but your training and the test will be on par when you fine tune your parameters in an appropriate way, okay? So this is again an example here. The red dots, green dots, I think you are able to see the difference between the red dots and the green dots over here. How exactly the network is able to learn during the training operation, right? Separate the red from the green dots. Look at here. It is representing the overtraining operation in a neural network. Overtraining. It is another scenario for overtraining. When you train more again and again, how exactly? Yes, this is another scenario what I would like to show. Yes, next. To improve the current convergence rate, yes, you can use a simulated annealing or any gradient descent methods. Okay, so accordingly, based on your application, based on your research work, you can choose and you can improve your convergence rate, and then your design will give you a better results and your pattern will give you a better results. The statistical pattern analysis, what you're going to do using your artificial neural network design, you'll be able to generate a better results in almost all the cases. All right. So next, what do we have here? ANN design. Design is also very important, as I told you. Basically, 3 layers we use, right? Input, hidden, and output. As I told you, how many hidden nodes, as we discussed before, the number of layers, it is up to you. You can have 1 input and 1 output. In between 3 hidden layers also you can have. How many number of layers you want to have? Yes, for a more complex problems. Yes, and how many hidden nodes you would like to have? The more the problem is complicated, the more the number of neurons and the hidden nodes and the hidden layers you need to use. But when you increase those things, definitely the complexity level is also going to increase. You remember, and we have to take a wise decision when we are choosing the number of hidden nodes, number of neurons, and the number of hidden layers as such. Okay. And finally, we'll be able to generate a result. The result will be either good or bad. Always, we cannot say that the results will be always good, the results will be always bad. No, it depends upon various factors, right? So based on the various factors, we'll be able to generate the results, all right? So this is just a sample pseudocode, just I would like to show, just I'll run through quickly. Input nodes, how do we, for each iteration, how do we represent? And then the hidden layer and the output layer, how exactly we calculate. Just it is a pseudocode of neural network. Here, activate the hidden layer and the calculation between the input layer and the hidden layer, and between the hidden layer and the output layer, and finally we will generate the output. Between input to hidden, from hidden to output, the final output we generate, that is output K over here. Just I'll run through, the time will not be sufficient for me to explain each and every line over here. So yes. Next, application areas where we can use this neural network, in what kind of a research we can use, in time series prediction we can use, modeling we can use, as well as pattern recognition, image processing, as well as novelty deduction, sequential decision making process, just to name a few. Radar system, face identification, handwritten text recognition, even in emotional intelligence also we can use this, as well as for data processing operation, including filtering, clustering, as well data mining operations, that is email and spam filtering. For all those operations we can use neural networks, right? So these are all the various applications what we can use it. Now the next one is, what we have here is the next slide. After applications of neural networks, we have what are the various applications of computational intelligence and neural network in our day-to-day life, right? So before that, advantages and disadvantages of neural networks. See here, adapt to unknown network situation. Yes, it is very powerful and you can find solution for any kind of a complex problem, and it learns by example, learns by pattern. Okay, so accordingly we can find out the better solution. Sometimes it forgets the pattern, sometimes it may not give the exact results, and it is for a large complexity of the network structure. Suppose when you are having a multiple hidden layer and all for any complex problem, that time we faces the problem. Okay. So next, what will be the ANN future? All right. So ANN future, see nowadays we are using. See, look at the symbols. ANN plays a role in almost all the daily walks of our life, right? See, in Google Chrome, in our mail, email operations, social media searching, stores and services, offline experiences, whatever it is, right? Just I'll run through quickly. Even in our email, as I told you, email spam filtering. It is Google claims AI powered filtering methods. By default, it is there. It automatically it goes to the spam if it is not related to you. Then here, just I would like to highlight one thing here. See here, received 3 days ago, but you didn't give the reply at all. Automatically, who is giving you the assistance? Yes, email reminders. It is automatically 3 days ago you received a mail. Automatically you need to send a reply. Sometimes you can set auto reply. If there is no auto reply, you'll be getting a gentle reminders. It is an AI powered Gmail. It is by default this operation is there. So you'll be getting an assistance to send a reply for that particular mail. That is a beautiful, amazing feature what we are using based on AI in Gmail, right? Even in LinkedIn, whatever, by looking at your profile, lot of employer can see your profile based on the matches. They will be calling you based on the demand in the market, right? So for that also in social media, how exactly AI is playing a major role. Yes. Next, chatbots. Chatbot is also very amazing feature. Like it automatically just you can see the conversation here. See here when you say cut and blow dryer $50, it is asking which day. When it is asking you which day, down you can see the day. For example, Monday, Tuesday, Wednesday. Then as soon as you can select any one, automatically it is providing the assistance to the user to provide the chat, whatever the chat you're going to chat bot. It provides a lot of add-on services to the user based on the current situation. See, when you type the particular cut and blow operation, it immediately asks you which day, and once if you select the date Tuesday 10th Jan, immediately it is asking you the time, at what time you would like to perform this operation. When you say the time, when you click on that, you're getting the operation here, like the message, yes, for thanks for booking for a particular service or whatever it is. It's an amazing feature. Unknowingly or knowingly, we are using it today. Even for our WhatsApp messages or whatever it is, we are getting all those options with us, right? So, next, Google predictive search. Even in Google, if you go and type, for example, what is the current situation of COVID, when the schools are going to open, when the colleges are going to open, you'll be getting a lot of assistance in that, right? So we call that as a predictive search. Google is having that is providing that facility. It is an AI enable feature, right? By analyzing the user's choice, it gives a lot of options. You can choose anything in the predictive, using the predictive analysis, right? So that is one amazing feature on predictive search, right? So the next one, apart from this Google predictive search, what do we have here? This is just an example. If we type state of market or the condition of COVID, you'll be getting lots, so many. Look at here, state of marketing 2018, state of marketing report, state of marketing technology 2018, and state of market report PJM. Lots and lots which is related to a particular predictive analysis. You'll be getting enormous. You can choose whichever you require for your particular. So all this AI based algorithm is helping us to choose all those things, but knowingly or unknowingly we are using all this. Okay, so product recommendations. Nowadays everybody is doing online shopping. When we are doing online shopping, when you're choosing for a particular product, automatically based on your choice, which gives you the recommendations. You're looking for some electronic gadgets, then automatically it will ask you, like if you say from lowest to highest price, then suppose if you're choosing for a particular, if you're looking for a particular brand, let's say OnePlus Mobile, or let's say MI, Xiaomi MI, or let's say Samsung Galaxy, or whatever it is. So when you're looking for a particular product or a particular gadgets, so based on the taste of the user, automatically it provides the assistance to each and every individual. It provides the assistance to each and every individual users. So by unknowingly or knowingly, even a person is a educated person or a non-educated person, everybody is using the computational intelligence and neural networks in their palm of their hand, but they don't know the technology, but they are using the technology today. That is how we are in. But we as a professionals, we are developing the technology for the people who requires to use the technology in their day-to-day life. Yes, if you want to travel from one place to another place, one location to another location, we are sitting in one place, our child is doing some kind of additional tuition classes or additional support classes or any dance drama classes, if you are sending, we are in work. How do we track our child? Yes, pick up and drop we couldn't do. Nowadays ride sharing apps are available, we can book. Yes, Uber uses AI, so you can fetch the location, like at what time your child is going to reach the home, at what time you are booking. If you send the data to your child, child can get into the vehicle and child will be dropped within the expected time. You can track where exactly the vehicle is. What is the time to reach? Another 4 minutes to reach home or 5 minutes to reach home. Now everything is there with us. It is all because of AI, computational intelligence, neural networks, and cloud. All this technology is being integrated into together to provide the service for the users. All right. So, what will be the future of this AI and neural networks? See here, in 2035, AI will only be 1 by 10 as smart as human. Okay, but by 2060, a survey says, okay, it can certainly do better. All right, but what is the market condition in 2035? AI market will grow up to $190 billion. Just imagine, where are we? What is the technology? What is the growth? It is a rapid and amazing growth. It is not going to kill the job of a human being. It is going to create a lot of opportunity for human beings. How? Because by equip ourselves with a lot of data science courses, neural networks, AI, computational intelligence, definitely to build each and everything. Everybody can't be the users. Somebody has to build, right? Somebody has to customize it. Somebody has to maintain it. So for that, a lot of job market is going to be there for AI based. These are all the features of AI. What are the futures of AI? Automated transportation, cyber technology, taking over dangerous jobs. See, for example, in chemical industry, even now in COVID situation, where nurses and doctors were not able to interact with the patients, right? So for that, we can provide robots in place of nurses, in place of doctors for the critical patients, like to handle that situation where the climate is not good. For all those things like in Himalaya, mountain ranges and all, we can use robots. And to take care of elder, when the people are on job, to take care of their elders at home, even at hospitals. Yes, we require. That is the future of AI. Just I have listed out few things, not everything. Yes. What are the free online AI courses available? Just for information, I would like to give you at the end of my session. I hope I have covered each and everything over here. Learn with Google AI and Google Machine Learning. Stanford is offering a machine learning course for free. Columbia University is offering a machine learning course for free. NVIDIA Fundamentals of Deep Learning for Computer Vision for free. MIT is offering deep learning for self-driving cars. These are all the online courses available for free. Maybe we can suggest for our students, for our teaching fraternity, for our colleagues, like the colleagues whomever is here now in the session. If you want to share, if you want to join, kindly make use of this particular session. I hope you all have enjoyed the session. Thank you very much for giving me the opportunity. I thank Shankari ma'am and the management and the HOD of the department for giving me this wonderful opportunity to deliver a neural network session using computational intelligence with each and every one of you. I thank each and every participants for joining the session. Thank you one and all. Let me handle the questions. If there is any question sessions over here, let me check in the chat window. If there is any questions, I am ready to answer. Kindly you can ask your questions over here. Any questions, audience? In the private chat, I'm looking at over here. I'm not getting any questions over here. Is there any questions? Kindly type the question in your chat window. I am there to answer your questions. I hope I have done within the time limit what has been given.
Participants, no questions at all. Participants, any questions? Ma'am, I will ask one question, ma'am, based on your
Yes.
presentations. How the human neurons, you are telling we are know about it, the neurons will be working just in human brains also. Am I right? How it is
Yes.
connected? Will you please explain it, ma'am?
Yes, actually, see, now when you ask me the question, I am able to answer or I am able to respond to your question immediately, right? Similarly, your doubt is how exactly the neural network is working by mimicking the human brain, right? So here, when you're designing a neural network, it accepts the external inputs, right? Let's say you're going to give 5 different inputs to predict the COVID situation. You need to give the name of the patient, age of the patient, and what is the severity of the condition, like what all the symptoms he or she has, right? All those data you're going to give. When you're giving this type of data, your system will have the capability. Now, if I am a doctor, physician, I will know if these are all the symptoms. Definitely, a patient is having a COVID-19 positive, or there is no possibility of having a COVID-19 with this mild symptoms. I am, as a human doctor, using my human brain, I will be able to take a decision. But how the neural network is going to take the decision? Using all this data set, whatever you have provided, and that weights, each and every weights what you're going to. Weight is nothing but the parameter values, and you're going to associate with each and every input. Okay? And then there is a transfer function. Transfer function in the sense, see, we call it as sigmoidal function, whether it could be a tansic function or loxic function. You can use either loxic or tansic function, and the number of neurons what you have given, the number of inputs what you have given, the hidden layer will associate with the weight and it calculates and then generate a result. The result when you get based on the inputs what you have given for a different set of people. Let's say you have feeded for 50 people or 100 people. These are all the symptoms, which gives you the result as maybe you will be getting as the range as 1 to 5. You can consider the result those who have got 3 to 5 ranges or COVID positive patient. Below 3 or non-COVID patient. This is how it works.
Okay, ma'am. Thank you for your great explanations. Now I understand how it is both, how it will be working. That's nice. Dear
Thank you.
participants, any other questions? No questions at all? Okay, we will end up the session. Thank you, ma'am, for your great, attractive, and informative sessions. Now we learned very well about neural networks in depth. AI also, I have introduced what kinds of applications, everything I learned very well. We've learned very well. Thank you again for sharing the knowledge with us. Okay, thank you, ma'am. You can end up
Thank
the
you, ma'am.
call. Thank you, ma'am. And one
Thank
more
you, ma'am.
information. Thank you, ma'am. And the informations to the participants, feedback link to be available in the command box. Kindly, all of you, submit the form within a half an hour. Then only we can consider it. Then after half an hour or within a 1 hour, we will close the responses. Thank you. Thank you.